Welcome to the deep dive. If you're tracking that intersection of frontier astronomy, data science, and global governance, well, today we're hitting probably the most critical policy document in that whole area.
Yeah, we're talking about the rules for what happens if or maybe when we actually confirm we've found extraterrestrial technology.
Exactly. So the source material for this deep dive,
It's a paper from the International Astronautical Congress, specifically IAC 25A4.2.4. The title is SETI Post-Detection Protocols, Progress Towards a New Version. And the authors are Garrett, Denning, Tenon, and Oliver. It basically documents this huge effort to update the rulebook. Start of 1-minute key insight summary for short format it.
Okay, let's do a quick rundown for everyone. The big takeaway. The old rules from 1989 and tweaked in 2010 were just broken. Totally focused on radio SETI.
Right, they didn't account for social media blowing things up instantly, or the fact that we're now looking for technosignatures much broader than just radio pings. Oh, and AI wasn't really a factor back then either.
And the new protocols, the 2026 update, they bring in serious technical demands, especially on data.
Huge emphasis on data integrity. Principle 4, it mandates that all the discovery data, the analysis methods, even the code has to be archived. And not just anywhere.
In two separate places, right? Geographically diverse.
Exactly. 2 independent repositories. It's about resilience, making sure that proof is rock solid and accessible.
There's also a big policy change in how these rules are adopted.
Yeah, they moved away from needing formal sign-offs from institutions, which always gets bogged down. Now it's framed as a collective community responsibility, more like technical best practice agreed by the experts themselves.
Much faster, much more actionable for the researchers on the ground.
Definitely, and maybe the most debated point.
Yeah.
What about replying?
The big one.
Principle 7 is now crystal clear. You have to wait. Consult internationally through the UN and others, but until those consultations conclude, no reply. Period. The default is silence.
Interesting. And one last thing, AI's role wasn't just why they needed new rules.
Right. The task group actually used AI, specifically ChatGPT, to help process all the feedback they got from scientists worldwide. Helped organize and summarize mountains of technical comments.
So AI helped write the rules designed partly because of AI's rise. End of 1-minute key insight summary. Okay, let's unpack that properly now. Why this massive multi-year effort? What was so fundamentally wrong with the 2010 update that they needed to, well, re-architect the whole thing?
Well, like we touched on, it wasn't just that the 2010 document was getting old. It was kind of functionally obsolete. It still had the bones of the 1989 original.
Which was written pre-internet, basically.
Exactly. Pre-high-speed internet, pre-social media saturation. Imagine trying to manage a global data event, like a discovery announcement, using rules designed when information moved at a snail's pace. It just didn't compute.
And things changed fast after 2010.
2 huge shifts. First, the communication environment. Any hint of a discovery now goes global, instantly, often uncontrollably. Second, the search strategy itself evolved way beyond just listening for radio signals.
Right, and that's key for a lot of our listeners, particularly those in data science and related fields. The shift away from just listening for like a deliberate hello signal.
Precisely. We moved to searching for general technosignatures. And just to define that term, it's basically any observable evidence of technology that was built or used by an extraterrestrial intelligence.
So that could be anything from what? Waste heat from massive structures.
Yeah, infrared excess from Dyson spheres or swarms, powerful laser emissions that look artificial, weird astronomical anomalies that don't fit natural explanations, maybe even physical artifacts if we ever found one. The old protocols were mostly about processing radio signals.
But the new ones needed to cover evidence that might be visual data, energy signatures, complex data sets.
Exactly. They had to create standards of evidence, verification procedures, data handling rules that could apply across completely different types of data. It's a much bigger technical challenge.
You mentioned this wasn't happening in a vacuum. There were other things going on in the academic world pushing this along.
Oh, definitely. The whole ecosystem was sort of gearing up. NASA's astrobiology program, for instance, was holding workshops on how we communicate discoveries, especially focusing on standards of evidence for biosignatures.
Science of life, not necessarily technology.
Right. But the rigor demanded for biosignatures naturally raised the bar for technosignatures, too. You also had the SETI Post-Detection Hub, founded at the University of St. Andrews in 2022.
Focus specifically on the societal side.
Yeah, what happens after detection. And then the International Institute of Space Law, the ISL, launched a working group on SETI and law in 2024. So you had the science policy people, the lawyers, the social scientists all saying, hey, we need a modern, technically sound framework here. The pressure was on the IAA SETI Committee.
Okay, so let's get into the how, the methodology. How did this task group actually manage to get useful, structured feedback from literally hundreds of specialists scattered across the globe? You can't just send a mass email and hope for the best.
No, you really can't. And the way they handled this consultation is actually one of the key technical aspects highlighted in the paper. It was very structured. They presented early drafts at the big IAC conferences in Baku in 2023 and Milan in 2024.
Gathering initial thoughts.
Right. Then, for the main consultation in spring 2025, they got clever. They used Google Forms, but with a two-part system for feedback on each specific principle.
Okay.
So, first, you could rate your satisfaction with that principle on a scale of 1 to 10, simple quantitative data. But then, you could also provide detailed written comments explaining your rating or suggesting changes. Anonymity was possible too, though they did collect optional demographic info.
So they got both numbers and the reasoning behind the numbers. Very smart.
Yeah, it gives you a sense of consensus and the specific technical points of contention.
And this is where AI enters the picture, not just as a topic for the protocols, but as a tool in making them.
Exactly. This is fascinating. They had all this written feedback, dense technical stuff coming from astrophysicists, data scientists, lawyers, engineers, you name it. Manually sorting and synthesizing that, it would take ages, and you risk subjective filtering.
So they turned to AI.
They explicitly used ChatGPT. The paper states they used it to help organize and summarize the written feedback, grouping comments by principle and topic. It helped identify where the strong agreement was, where the conflicts were.
Basically speeding up the process of finding the signal in the noise of all that expert feedback.
Precisely. It let the task group focus their human expertise on resolving the substantive, technical, and policy disagreements rather than getting bogged down in just, collating text.
Okay, so after using AI to process that round, they put out another draft in August 2025. How widely did that one go? Who got eyes on it?
They went really broad with that one. The paper says over 350 individuals. This covered the usual suspects, the IAA SETI Committee members, the space law experts involved with the ISL group.
And also some newer networks.
Yes. Crucially, they included two other key groups. One was the SETI Post-Detection Hub Community, 50 people, and the other was the Order of the Octopus.
The Order of the Octopus. Sounds intriguing.
It does, doesn't it? It's actually a network of mostly early career researchers, around 120 of them, specifically focused on SETI and technosignatures.
Ah, so making sure the next generation of researchers, the ones who might actually use these protocols, were bought in.
Exactly. It ensured the protocols weren't just reflecting the views of the, let's say, established figures, but were practical and relevant for the people likely to be doing the work in the coming decades. And the feedback they got was overwhelmingly positive.
What were the numbers?
Over 70% of the respondents rated that August draft an 8 or higher out of 10. And the feedback was balanced, too, across different ages, genders, career stages, and areas of expertise. It showed they genuinely built a strong consensus across this very diverse technical community.
Okay, let's shift gears then to the actual content changes. The new architecture. You mentioned earlier, one of the biggest shifts wasn't even a rule, but how the rules get adopted, this endorsement structure change.
Yeah, this is a really clever piece of policy engineering, actually. It's designed to make the protocols effective much faster. See, the old way required formal signatures from institutions, maybe even governments down the line.
Which sounds like a recipe for getting stuck in bureaucracy forever.
Totally. International politics, institutional inertia. It could take years or just never happen. So the new approach flips it. It frames these protocols as the collective responsibility of the international SETI community.
Meaning
They're treated more like technical best practices, standards agreed upon by the scientists and researchers themselves. It bypasses the need for slow, formal government or institutional ratification. Once the scientific community, through the IAA, endorses them, they're basically considered the standard to follow.
much more agile. Okay, let's get into the technical requirements now. Principle 1, handling candidate evidence. What does it say about the moment someone thinks they might have found something?
Principle 1 lays out a really strict immediate process. If you have candidate evidence, you must try to get it authenticated independently, and not just by asking a buddy with the same telescope to look.
It needs to be different methods.
Yes, by multiple facilities using fundamentally different instrumentation. That's key. Verify it with a different type of telescope, a different sensor, a different analysis pipeline. It builds robustness against systematic errors or instrument artifacts.
Makes sense. Avoid putting all your eggs in one technical basket.
Exactly. And alongside that, the revised preamble really hammers home the need for cautious public communication, emphasizing that initial findings are often ambiguous, incomplete. Scientific integrity comes first.
That communication piece leads right into principles 2 and 3. You mentioned earlier they now explicitly include the term risk communication, not just science communication. Why the addition?
That's a really important distinction. Standard science communication is about explaining the science, educating the public. Risk communication is a specific discipline focused on communicating during high-stakes, high-uncertainty events where there's potential for, well, public anxiety or disruption.
And a confirmed ETI detection definitely qualifies as high stakes and uncertain.
Absolutely. It's arguably the definition of it. So organizations involved need to be prepared not just to announce the facts, but to manage public fear, address wild speculation, be transparent about what they don't know yet. It's about managing the societal response, which is a technical skill in itself.
Okay, now for the data folks listening. The consolidation of principles 4 and 5 on data accessibility and archiving. This sounds like one of the most technically demanding changes, especially the requirement for 2 geographic repositories. Why so specific?
This is all about ensuring the absolute integrity, longevity, and accessibility of the evidence. If this is the biggest discovery in history, you cannot risk losing the data. The mandate is that all the crucial data, the raw observations, the process data, the analysis methods, even the software code used, must be preserved.
The code, too. That's crucial for reproducibility.
Hugely important.
Yeah.
And it all needs to be archived securely in at least 2 repositories located in different geographic jurisdictions.
Why 2 and why geographically separate?
Redundancy and resilience. It protects against everything. Natural disasters wiping out a data center, technical failures, hardware degradation over time, but also political issues.
Like one country deciding to classify the data.
Exactly. Or restricting access. Having it in 2 separate legal and geographic locations provides a massive safeguard. It ensures that the global scientific community retains access to this fundamentally important data long-term. They also strongly recommend using open standards and established international archives. It's a built-and-braces approach to evidence preservation.
Makes total sense for something of this magnitude. Okay, let's tackle Principle 7, the big one. Should we reply? You said the final draft is definitive.
It is. After undoubtedly a lot of debate within the task group and the community, they landed on a very clear, cautious stance. Now, it's important to note, the declaration explicitly doesn't cover VTI that's messaging before we detect anything. That's a whole separate can of worms.
Right. This is purely about the response after a confirmed detection.
Correct. And the rule is, SETI practitioners must work with the UN and other broadly representative international bodies to consider any potential reply. But crucially, pending the outcome of such consultations, no reply should be sent.
So the default is coordinated international silence until a global consensus is reached on whether and how to respond.
That's it. It prevents any single nation, institution, or even individual from making a unilateral decision to reply, which could have, unknowable consequences. It mandates patience and global discussion first.
Wow. Okay. And finally, Principle 8 wraps up the ethical and legal side. Anything particularly new there?
It strengthens the language around adhering to the highest ethical standards and complying with relevant laws, obviously. But it also adds a new, really important clause about protecting the safety of researchers.
Safety? In what sense?
Well, history shows that scientists involved in major, potentially world-changing or controversial discoveries can face intense pressure, scrutiny, even harassment. Think about discoveries with national security implications, or just things that capture massive public attention.
Right, the human element.
Exactly. This new clause explicitly recognizes that risk and mandates that institutions should cooperate with authorities to set up frameworks that protect the individuals involved. It ensures that the vital tasks of data handling and public reporting can happen without putting the discoverers themselves at undue risk.
That feels like a very necessary, pragmatic addition. So we've got this revised, technically robust draft shaped by AI and expert consensus. What happens next? How does this become the official 2026 update?
It's in the final stretch now. The draft we've been discussing, the one dated 25 September 2025, is being presented right now, basically, at the IAC 2025 conference in Sydney.
So getting final exposure to the community.
Yep. And following that presentation, the next step is a formal vote by the members of the IAA SETI Committee. That's expected before the end of 2025. It'll be done via a secure, anonymous online system and needs just a simple majority to pass.
And assuming it passes, which seems likely given the feedback.
Then the committee submits the approved version to the top brass, the IAA Board of Trustees. They'll review it for endorsement, likely in the first half of 2026.
And if the board gives the green light?
Then it's official. The protocols will be formally presented as the 2026 update at the next IAC, which is scheduled for 2026 in Antalya, Turkey. And at that point, it becomes the globally recognized best practice framework.
It really represents a shift to a more durable, flexible system, doesn't it? Grounded in the technical realities, but also responsive to the legal, social, and policy complexities.
Absolutely. It strengthens the community's ability to respond in a way that's coordinated, transparent, and above all, scientifically rigorous.
It is quite something, though. All this effort, all this technical consensus building for an event that, let's be clear, hasn't actually happened yet. Developing rules for the unprecedented.
It's a unique challenge, for sure. Which leads to maybe a final provocative thought for you to consider.
Go on.
We talked about how the task group used AI, ChatGPT, to help process the feedback and draft these protocols. And we know that the rise of AI, its potential role in signal analysis, was one of the reasons these protocols needed updating so badly.
Right.
So the question is, given how fast AI is developing, how long will this 2026 declaration remain adequate? What happens when AI isn't just helping us draft the rules, but potentially making the discoveries itself, maybe analyzing signals in ways we don't fully understand yet?
If AI starts finding potential technosignatures autonomously?
Do we need another revision? Maybe protocols for dealing with non-human discovery intelligence? It really highlights the accelerating pace we're dealing with.
That definitely puts the speed of change into perspective. A fascinating point to end on. Well, thank you for walking us through the intricate details of these vital new protocols.
My pleasure.
And for you listening, we really encourage you to look deeper into some of those specifics mentioned, like the standards for risk communication and data archiving. These aren't just abstract rules, they're the technical bedrock for how humanity might handle its most profound discovery. We'll see you next time on The Deep Dive.